Dear viewers, welcome to my YouTube channel Electrical Passionate. Today in this video we shall discuss about application of IDMT relays and calculation of relay operating times for protection of a radial feeder. The video will take a few more times for complete discussion of the subject. No doubt this is not easy to define the subject. Please keep your patience during watching this video. During calculation of relay operating times, in order to calculate the actual relay operating time, the following terms must be known: time PSM curve, current setting, time setting, fault current, current transformer ratio CTR. The procedure for calculating the actual relay operating time is as follows. Convert the fault current into the relay coil current by using the current transformer ratio. Express the relay current as a multiple of current setting, that is, calculate the PSM. From the time PSM curve of the relay, read off the time of operation for the calculated PSM. Determine the actual time of operation by multiplying the above time of the relay by time setting multiplier in use. The following example illustrates the application of IDMT relays for protection of a radial feeder. Consider the radial feeder as shown in the figure. What is a radial feeder? When a number of substations are fed by a single feeder, then the feeder is called a radial feeder. The CT ratio and maximum fault currents of various substations A, B, C and D are indicated. For practical purposes, we proceed to calculate the time setting of IDMT relays with maximum fault current. Starting with the relay at D, the TMS has to be the lowest. Let us say it is 0.1. Now, if the load current does not exceed 100 ampere, then the relay current setting may be set as 50%, that is 0.5 ampere, as CTR is 200 by 1. Therefore, PSM is equal to maximum fault current divided by relay current setting into CTR is equal to 2000 by 0.5 into 200 by 1 is equal to 20. From standard IDMT curve, the operating time for a PSM of 20 is 2.2 seconds. But as the TMS is 0.1, the actual time setting at D will be 2.2 into 0.1 is equal to 0.22 second. Now, for the same current 2000 ampere, the relay at C must be set to discrimination of 0.5 second longer than the relay at D. That is, at 0.22 plus 0.5 is equal to 0.72 second. The relay current setting at C must be increased as compared to that at D. The same increase is being provided with the help of higher CT ratio at C. But still, to allow for any increase in load caused by the load at D, the relay setting at C as 100%, that is at 1. Thus, for maximum fault current 2000 ampere, PSM is equal to maximum fault current divided by relay current setting into CTR is equal to 2000 divided by 1 into 300 by 1 is equal to 6.66. PSM 6.66 gives a time of 3.5 second from standard IDMT curve. For an operating time of 0.72 second, the time setting should be TMS is equal to 0.72 divided by 3.5 is equal to 0.21. For faults closer to C, where current is 3000 ampere with 100%, that is 1 ampere current setting, the PSM is equal to 3000 divided by 1 into 300 by 1 is equal to 10, which gives a time 3.0 second with a TMS of 0.21. The actual operating time at C is 3.0 into 0.21 is equal to 0.63 second. Now at B, the required operating time for a fault at C is equal to 0.63 plus 0.5 is equal to 1.13 second. Increasing the current setting at B to 150%, PSM is equal to 3000 divided by 1.5 into 300 by 1 is equal to 6.66, which gives a time of 3.5 seconds from standard IDMT curve. Therefore, TMS is equal to 1.13 divided by 3.5 is equal to 0.324, say 0.32. For faults closer to B, where current is 5000 ampere with 150%, that is 1.5 ampere current setting, PSM is equal to 5000 divided by 1.5 into 300 by 1 is equal to 11.1, gives a time 2.75 seconds from standard IDMT curve. which gives the time 2.95 second with a TMS of 0.32 from time current curve shown earlier. The actual operating time at B is 2.95 into 0.32 is equal to 0.944 second. Now at A, the required operating time for a fault at B is equal to 0.944 plus 0.5 is equal to 1.444 second. Now the current setting at A is automatically increased without the relay current by virtue of its CT ratio. So, keeping the relay setting at A 150%, same as that of relay at V, PSM is equal to 5000 divided by 1.5 into 400 by 1 is equal to 8.34, which gives a time of 3.2 second. Therefore, TMS is equal to 1.444 divided by 3.2 is equal to 0.452. For faults close to A, where the current is 6000 ampere with 150% current setting, PSM is equal to 6000 divided by 1.5 into 400 by 1 is equal to 10, which gives off 3.0 second. Therefore, actual operating time at A is equal to 3.0 into 0.45 is equal to 1.35 second. So the time setting at D 0.22 second, at C 0.63 second, at B 0.944 second, and at A 1.35 second. Now please subscribe to my channel, like and share the video. Thank you for watching this video.